Hello everyone, this is Prabhjot Kaur and welcome to the third video of data structure series. In this video, we will understand what is algorithm. We will also look at its characteristics, and at the end, we will look at a very simple example of algorithm. In the previous video, we understood what exactly is the problem and how to analyze it, and then we also looked at the 6-step formula for coming up with the best solution of a given problem. If you haven't watched that video, I suggest you to first watch that video and then come back here. Now let's understand what exactly is the algorithm. Typically saying, an algorithm is defined as a step-by-step procedure or method for solving a problem by a computer in a finite number of steps. I think we need to divide this definition into simple chunks. So let's move and let's simplify it. Now, firstly, the algorithm should have a series of steps. When I say series of steps, I'm talking about the sequential flow of the steps. Like it should start with step 1 and so on up to step n, depending upon the problem and the number of steps that need to be designed for a given algorithm. And these series of steps should come one by one. Like if step 2 should come after step 1 and similarly and so on. Step n should come after step n minus 1. Algorithm defines a logic to solve a problem. Now logic is, we can say, is solution. We have a problem at hand and now we are working on it to come up with the solution. So that is why we are designing algorithm, because one of the approach to solve a problem is the algorithmic approach. So the algorithm is going to provide a logic for specific problem, and there can be multiple logics for one problem. So that's why we will be having different algorithms and we will be choosing best one. The algorithm should be understandable by the humans. It should be written in such a way so that we can understand what exactly the logic of that algorithm is. Algorithm is not going to be put into the computers directly, because this is just for us to understand the logic for a given problem, for understanding a logic for solving a given problem. It should be written in a simple language. It should be written in a simple language, and we can prefer English-like structure, because this is how we will understand, we human beings will understand what exactly we have to follow. This thing will be clear to you when we will look at the example. The next thing is, algorithm should be independent of any sort of programming language, because we are just defining the logic to solve a problem and we are not concerned with specific programming language. So why we need not to talk about programming language at this stage? Because we are concerned with just the logic of the problem. So we will not talk about any sort of programming syntax when we will be writing an algorithm. So this thing should always be kept in mind when we are designing or writing an algorithm. When we will choose one programming language and we will try to execute that algorithm, that is going to become a program of that particular language. For example, I have chosen C++ language and I want to execute the algorithm for some sort of problem. So that is going to be called as C++ program and not the algorithm itself. And similarly, if the same algorithm is written in the different language, like in Java language, that is going to be called as Java program. And similarly, in other languages like ASP program and so on, depending upon what programming language you are going to choose. First thing, the algorithm should be free from ambiguity. And by ambiguity, what I mean that one algorithm should convey only one meaning, and it should not confuse anyone by giving a double meanings. So only one statement or whatever is written in the algorithm, that should convey a single meaning. Second is, algorithm should have some sort of input, because this is the main raw material on which algorithm have to work. So there should be a proper input for a given algorithm. Next, it should provide output back to the user. That is going to be the final result. Because this is why we are writing the algorithm. We are actually solving the problem. And why we are concerned with the problem? Because at the end we want an end product, and that is going to be the output. If algorithm is not giving the output, what will be the use of that algorithm? So a good algorithm should have output at the end of its steps. Next is finiteness. By finiteness, I mean that it should have fixed number of steps. If algorithm is executing in a loop, it's never gonna stop. So how can we come up at the output? So for reaching an output, algorithm should have fixed number of steps so that we can come up with the results in a finite time. Finite means that we can count. Next is feasibility. If you have studied software engineering, one of the steps in SDLC cycle is feasibility. So feasibility means the algorithm that you are trying to develop or build should be feasible depending upon the provided resources. And that resources can be hardware, software, or anything. We should be aware that the algorithm that we are trying to build should be feasible in a given set of resources. Last thing is independent, which means an algorithm should have step-by-step directions, which should be independent of any programming code. We have seen in the previous slide that algorithm should not be confined to only one specific programming language. So it should be independent of any programming language, because we are just concerned with the logic and we want just the solution or the pseudocode. For making everything clear to you, let's say an example of adding two numbers. So we have this problem. There can be many logics, but we are going to write a simple logic, a simple algorithm for this problem. So this is our problem. We are going to write algorithm for this problem by keeping in mind all the characteristics. Let's write step 1. As we know, algorithm is step-by-step process for solving a problem. So step 1 is going to start. Simple one that we will start. Step 2. We will declare three variables. Declare three variables A, B, and C. Next thing is we will define the values for two numbers. Step 4. We will add the values of A and B. Step 5. We will store the output from step 4 into C. Step 6 is going to be print the value of C that we just saved in step 5. Step 7, stop the execution. Now it is clear from this example that we have looked into all the characteristics of algorithm while writing it. First, it is written in a simple language. It is independent of any sort of programming language. It has an input and it gives back the output. It has finite number of steps. And each statement or step of this algorithm conveys just the one meaning. I hope the algorithm is clear to you. If you found some value in this video, please hit the like button and consider subscribing to this channel along with hitting the notification bell. Thank you so much.